You've seen them, right? These absolutely massive, towering walls of concrete you see on highways that are carved into hillsides. We drive past them every single day and probably never give them a second thought. Well, today we're going to dive into the fascinating, surprising science behind these superwalls.
I mean, really, stop and think about the physics for a second. How in the world does a relatively thin wall of concrete blocks manage to hold back the crushing weight of an entire landscape? What invisible force is stopping all of that earth from just collapsing right onto the road? That is the exact question we're answering today.
Okay, so these things actually have a name. They're called reinforced soil walls, or RSE walls for short. And let me tell you, they are the absolute workhorses of modern civil engineering. They are everywhere, making it possible to build roads and bridges and terrain that would have been completely unthinkable just a generation or two ago.
All right, so let's start with the part we all recognize. It might look like a simple stack of blocks, but what you're seeing is just the skin of a much more complex and, frankly, genius system. There is so much more happening right behind that facade. Here is the fundamental problem engineers are wrestling with. Soil is unbelievably heavy. A single cubic meter of it can weigh as much as a small car. Now multiply that by the size of a whole hill. Gravity is constantly trying to pull that immense weight down and out. The job of an RS wall is to defy that powerful, relentless force. And you've probably noticed they come in a few different styles, right? Sometimes they have these neat, interlocking concrete panels. Other times, they look like big wire cages just full of rocks. But don't let the different looks fool you. The secret to their incredible strength is exactly the same, and it's completely hidden from view. All right, you ready? It's time to peel back the curtain and look at the anatomy as one of these superwalls. This is where the real magic happens. So check this out. This blueprint shows us that the wall isn't really a wall in the traditional sense. It's not one solid, massive block fighting the earth. It's a composite system, a structure made of several different parts, all working in perfect harmony. So let's break them down, starting from the outside and working our way in. First up, you have the facing. This is the part we see from the road, those concrete panels or blocks. Its main job is just to keep the soil from spilling out at the very front and to give the whole thing a clean look. It's important, yeah, but, and this is the key, it is not where the real strength comes from. Right behind that facing is the reinforced fill, and this isn't just any old dirt they scooped up from the side of the road. No way. This is a specific type of granular soil, very carefully chosen and compacted in precise layers. This soil mass forms the actual body of the entire structure. And this is the star of the show, the reinforcement. These are layers of incredibly strong material that are embedded within that soil, running from the facing deep into the hillside. This hidden network is the secret sauce that transforms a loose pile of dirt into a massive, stable, and unbelievably strong structure. So, how does the secret ingredient actually work? Well, the best way to think about it is that the reinforcement turns the entire mass of soil behind the facing into a single, gigantic, gravity-defying brick. It just unifies the whole thing. These reinforcement materials are part of a family of products called geosynthetics. They're basically engineered polymer grids or fabrics with just mind-boggling strength. You know how you see steel rebar used to strengthen concrete? This is exactly the same idea, just on a different scale. This is, quite literally, rebar for dirt. And this rebar for dirt comes in a few forms. Two of the most common are geogrids, which are these stiff, grid-like sheets, and then you have geostrips, which are like incredibly strong polyester straps sheathed in plastic. Both are laid out in layers as the wall is built, using the power of friction to lock all the soil particles together. So, how do you even build one of these? Well, constructing a superwall is like following a very precise, very high-stakes recipe. You absolutely cannot wing it. Every single component, every single step has to be perfect. And that precision starts with the soil itself. You can't just use any dirt. The reinforced fill has to meet incredibly strict criteria. For starters, it can't have rocks that are too big, because they could damage those important reinforcement layers. It needs a high friction angle, which is just a technical way of saying the soil particles have to be grippy enough to create friction with the geosynthetics. And finally, it needs a low plasticity index, which means it can't have too much clay so that water, the ultimate enemy, can drain right through it. And speaking of water, it is the #1 threat to these walls. If water builds up in the soil, it creates this immense pressure,
a force powerful enough to push a wall clean over. To prevent that catastrophe, engineers often build a vertical chimney drain right behind the reinforced soil block to capture any water and channel it safely away. And none of this is guesswork. The design and construction of these walls are governed by extremely rigorous international standards, from the FHWA in the US to specific codes in the UK, Europe, and India. These codes make sure that every single factor, from soil type to reinforcement strength to earthquake forces, is meticulously calculated. Okay, so let's zoom back out. Because when you understand how these walls actually work, you start to see the hidden engineering that literally shapes the world we live in. These walls truly are the unsung heroes of modern infrastructure. Without this technology, building the roads, railways, and bridges we rely on through hilly and mountainous regions would be astronomically expensive, or in a lot of cases, just physically impossible. They quietly and reliably hold our world together. And that's really the core idea here. It's such an elegant feat of engineering. It takes one of the most common and seemingly weak materials on Earth, plain old soil, and by adding a clever reinforcement system, transforms it into a unified, powerful structural element capable of holding back a mountain. So the next time you're on a highway and you pass one of these massive structures, what are you going to see? Will it just be a wall of concrete blocks? Or will you see the invisible network of geosynthetics, the carefully engineered soil, and the brilliant science that's silently holding our world in place?